So now we're going to go in, for this last part of the lecture, we're going to be going into layering of the Earth. And we're going to talk about layers by composition. And layers by how they behave by material behavior, or rheology. Rheology is called. What we're going to see here is that the layering of the Earth is a product of Earth's formation process and ongoing heat transfer from core to surface. Core to surface. There we are. And that there is some overlap in layers by composition and layers by material behavior, but there's also some important differences between the two. So, and this fundamentally will also help us start to understand certain oceanographic phenomena that we're going to be looking at beginning, well, as soon as Thursday. So, yes. All right, I'm going to pause this. So you slice up Earth like a giant pie wedge. From the Earth's surface to the Earth's center is about 6,371 kilometers. Over half that distance, from a little under half that distance, is covered by Earth's outermost layers. Using a smaller font. A little under half that is covered by Earth's outermost distance. The rest of it is the core. So Earth's innermost layer is known as the core. This is also the densest layer. And so when looking at Earth, we're going to be looking at layers both by what they're made of. So here, I'll put little layers by material composition or chemical layering of the Earth. And we're also on the other side of this diagram going to be looking at layers by rheology. Rheology, again, is just a fancy word for physical properties, material properties. Kind of like if you have a Snickers bar and you put in the freezer, it's going to have a very different material behavior than a Snickers bar that is sitting on the dash of your car or in your glove compartment on a warm day. And so layers by material composition are generally going to be sorted based on density. With the densest materials towards the center, because at one point we were entirely looking. Layers by material composition are going to be density controlled, and your layers by material composition are going to be density controlled. And so what we find in Earth's center is the core. iron and nickel. Uh, Core is going to be made of iron, nickel, and sulfur, and is all the dense stuff that sinks to the Earth. Above the core, you're going to have the mantle. And again, we find mantles on all planets. Notice I'm using green here. This is going to be made of peridotite and be a little bit and comprise most of the volume. So then finally we have this sort of outermost layer. And this is again stuff we don't see a lot of, though I do have some green mantle rock here. Then finally we have this sort of outermost layer. We have, through most of the ocean basins, we have a crust made of basalt. This outermost layer is actually quite thin. I'd say between about 6 kilometers thin or thick or something like that. We have the ocean crust. Salt. And this ocean crust is primarily made of a rock called basalt. And it tends to only be about 5 to 10 kilometers thick. But and indeed, if the crust in general, if Earth were the size of an egg, the crust would be about the half the thickness of the eggshell. But that's not the only crust out here. We also have a second variety of crust. We have your continent crust. Which is made primarily of granite. This one is going to be a little thicker, and this is also why the land masses are ride a little higher, because they're on thicker material in general. This is going to be about between about 20 to 70 kilometers. 25, 70 kilometers. 70 kilometers is going to represent some very thick crust that you'll only see in very big mountain ranges. Yeah, this is what the Earth is made of.